honestly, someone made them up, okay? They're a made-up kind of number. So what happens when you take a square root of a negative number?
There's an error.
You get an error, right? Or you get like an unreal solution. Remember we say no solution? Because you can't possibly take the square root of negative 25 and find two of the exact same number that would multiply to make negative 25, right? You've got to have one positive, one negative to multiply to make a negative. The problem is mathematicians didn't like that very much, and that made some things in math not work the way they should, okay? It made it so that when you were using the quadratic formula, if it came out to be a negative discriminant, you would get an error and things like that. So mathematicians didn't like that very much. So they created something called the imaginary numbers, okay? Now I'm going to be very honest with you. I don't know what the applications of imaginary numbers are. I guess there are some, all right? In fact, one of those websites I posted yesterday, I found a list of ways that they're used. But for the most part, imaginary numbers exist to make other math easier, to make it so that other math works out without getting errors all the time, okay? Any other topic we talk about this year, I can usually find some way that math is used somewhere. This one I have a hard time with, okay? Because like I said, they're made up numbers. They are something that a mathematician said, you know, I don't like that I can't find an answer to this problem, so I'm going to create an answer to this problem. The good news is they're easy. They're really, really easy to work with, okay? But it just is a little bit contrived, a little bit like made up. I don't know another word to say that, but so let's talk about what an imaginary. So imaginary numbers again were created so that you can take a square root of a negative number. Okay? Is that something you guys had to write down? Oh, I guess not. Okay, I guess I didn't need to go back. But so again, imaginary numbers allow us to take the square root of a negative number. That's the whole reason they exist. Okay? So the imaginary unit, which is like what makes a number imaginary, we use the letter I. And I is equivalent to the square root of negative 1, which we know should not exist, right? We know that the square root of negative 1 should not exist. But someone said, well, I'm going to say that the square root of negative 1 is called I. I'm going to call it I. I'm going to name it I. Okay? I for imaginary because mathematicians are not creative. Okay? And here's how they work. Let's say I have the square root of negative 9. Okay? Well, I could take that square root of negative 9. First, I'm going to make sure my marker is set right. And I could write it as the square root of negative 9. Nope, sorry. Square root of positive 9 times the square root of negative 1. Do you agree with me? That I could take this negative 9 and separate it out into a 9 and a negative 1. 9 times negative 1 makes negative 9. Well, what's the square root of what's the square root of 9? 3. And what did we just say we're going to call the square root of negative 1? I. So we would say our answer to this, square root of negative 9, is 3i. Okay? That's how they work. What's the square root of negative 25? 5i. Okay? If it's a negative number, you just tack an I onto it. Square root of negative 64. 8i. Okay? It's not a negative answer. You don't say negative 8i. Okay, just like here we don't say negative 3i. It's just the square root of this number with an I attached to it. Okay? Does that make sense? Hopefully. Okay. Let's say I give you this. X squared equals negative 100 and I tell you to solve it. Meaning I want to know what x equals. How would I solve something like that? Square root it, right? So I would say, all right, I'm going to square root this and square root this. And here I would get x. What's the square root of negative 100?
10i.
10i, good. Okay, 10i Now, do you remember when we solved these before? You don't have to write this part down, but when I gave you problems like x squared equals 100, and you did a square root, do you remember that you got two different answers? Okay, you got x equals plus or minus 10. That same thing happens here. So this 10i should have a plus or minus in front of it. That only happens, that plus or minus only matters when it says solve. Okay? When the problem says to solve it, to find what x equals. That's when the plus or minus matters. Okay? Any other problem, you don't have to worry about the plus or minus. But if it says solve, throw in the plus or minus. Okay? Everyone see where we got the I from? The I came from because we took a square root of a negative. Anytime you've got, now before, remember I told you would just say no solution for this. Really what we're doing is we're saying, okay, we're going to call the solution 10i. We're giving it a different name. Okay? Next here. Okay, let's talk about I squared, because I squared pops up quite a bit in the next couple of sections. If I want to take I and square it, well, what's I equal to again? Just I by itself? Almost. It's not just -1, it's the square root of -1. So I is really the square root of -1. If I take a square root and square it, I feel like I'm talking Dr. Seuss language today. If you take a square root and square it, what happens to it? Like what happens when I have a square root squared? Yeah, it cancels out. The square root and the square cancel, and I'm left with just -1. So this is a big thing that you want to just commit to memory. Okay, I mean, understand why it works, but commit to memory that anytime you see I squared, that's equal to -1. Okay, so I by itself is the square root of -1. I squared is just -1. Okay, and that's going to come in handy because there's going to be times that you want to take an imaginary number and make it not an imaginary number. And notice that -1 is not an imaginary number. It doesn't have an I on it. So if you take an I and square it, you can change it from imaginary to real. Okay. Questions so far? Everything going okay so far? Okay. Show that I square root of 7 is a square root of -7. Well, let me, and you don't have to write this part down, but I'm going to throw in another example here. Hold on just a second. Let's say I were to tell you, and again, you don't have to write this down, prove to me that -5 is a square root of 25. How do you show that something is a square root of something else? Good. Yeah, that's what it means to be a square root, right? Is if you square it, it should turn back into the number. So the way I would prove that is I would take -5 and square it and show that it equals 25. Okay, that's how I would prove that something is a square root. So now knowing that, let's says show that I square root of 7 is a square root of -7. What am I going to do to this? Square it and show that it comes out equal to -7. Okay? So I'm going to say I square root of 7 squared. I'm going to start with that. I'm going to take it and square it. Well, what that's really going to do is that's going to square the I, and it's going to square the square root of 7. So I'm going to turn that into I squared times the square root of 7 squared. What does I squared equal? -1. So I squared equals -1. What's the square root of 7 squared? Just 7. Yeah, square root and square cancel, so that becomes just a 7. And what's -1 times 7? -7. Okay, which is what I was trying to show. I was trying to show that the answer would come out to be -7. Okay, so when I ask you that question, all you have to do is take this and square it and show me that it equals this. But remember, you're trying to show me, you're not just telling me. So you can't just say, well, I square root of 7 squared equals -7. I want you to show me this breakdown. I want you to show me how you got to -7. Okay. Okay. We do have a lot of examples today. Okay, some simplifying ones. Square root of -4 minus square root of -49. What's the square root of -4? Careful. Square root of -4. Do you know when you just won't speak? Or do you not know? Okay, I've seen at least 5 people mumble it. Somebody say it with confidence. Thank you. Yes, square root of -4 is 2i. Because the square root of 4 is 2, and when you take the square root of a negative, you get an I, right? All right, square root of -49. 7i, good. And these are being subtracted. Now from here, you can just treat I like a variable. So like if this was 2x minus 7x, you're going to do the kind of the same thing. So what would 2i minus 7i be? What's 2 minus 7? -5. So this would become -5i. Okay, just like if it said 2x minus 7x. Okay. What do you get when you do 6i times 4i? 24. What's I times I? I squared. So you get 24i squared, right? But what's I squared really equal? I squared is really a -1, right? So what's 24 times -1? 24 times -1?
-24.
Thank you, -24. Okay, so when you have a number with an I squared attached, okay, when you have a number with an I squared on it, that number is really just going to turn negative because it's being multiplied by -1. Okay, so if I had 5i squared in my problem somewhere, that would really be a -5. Okay, if I had 12i squared, that would really be a -12. Some more. Okay, square root of -36. What is the square root of -36? 6i plus, now this 3 I'm just going to leave alone for a second. What's the square root of -4? 2i. Now look at this right here. 3 times 2i. What does that equal? 6i. So this is really 6i plus 6i, which is 12i. 6i plus 6i is 12i. Would that become an I squared on that one? No, because you're not multiplying. Okay, I squareds only come up when you're multiplying. Okay? All right, square root of -25.
5i.
5i, square root of -81.
9i.
Good. Now, what would happen with that fraction? What do you think would happen?
That's a final answer.
Almost. If I had 5x over 9x, what would you be able to do? You can cancel out the i's, right? So I could take the i's and cancel them, and then my answer would just be 5 over 9. Okay, that would be final answer because your i's cancel. Does that make sense? I'm doing all of these examples, by the way, because your homework assignment is really just a whole bunch of these kinds of problems, and I'm trying to hit kind of one of everything you might see tonight's homework. Okay, square root of -36 times square root of -64. Okay, what's square root of -36? 6i. Square root of -64? 8i. What's 6i times 8i? 48i squared. And what's 48i squared really equal to? -48. Yep, because I squared is really -1. So this is really 48 times -1, which is -48. What you want to watch out for, and this is one of those things that I feel like I have to point out My writing might disappear. Yeah, okay. I have to point this out mathematically to show you what happens if you do this, but this is one of those things that I would not expect anybody to ever do. Normally, when you're multiplying two square roots, you should be able to just multiply the two numbers together. Hi.
Hi, sorry for interrupting.
That's all right.
5 for you.
All right, thank you. I'll get those handed out.
Thank you.
Normally, if you're multiplying a square root times a square root, you should be able to just multiply the numbers inside together and then just do one square root problem. The problem is here, if you multiply them together, if I multiplied these together first, it would come out to be a positive number, and then you would lose the imaginary part. Okay, so when it's two negatives, you can't multiply the numbers together first, even though probably most of you would not have thought to do that anyway. Just thought I'd point that out. Okay. Simplifying is a little different, okay? And we're going to spend a lot of time when we get to chapter 8 on simplifying. We're just sort of getting our feet wet with it right here. Simplifying a square root means don't just type it in your calculator and get a crazy decimal, because we don't know the square root of 12 off the top of our heads, right? What are some perfect squares? Well, let's start with this. Let's just list the numbers that are perfect squares. Can somebody tell me a number that's a perfect square? Do you know what I mean by perfect square?
4.
Okay, 4 is a perfect square because I can take the square root of 4, right? Okay, so 4 is a perfect square. 1 is a perfect square. So this is 1 squared is 1, 2 squared is 4. What would the next one be? 9. Okay, 9. What would the next one be? 16, because 4 squared is 16. 5 squared is 25. 6 squared is 36. I could keep going, right? Okay. So those numbers are the perfect squares. And in the next couple of chapters, you're going to be working with these numbers quite a bit. So you're going to want to get to the point, I mean, you don't have to go home and like study this, okay? But you're going to want to get to the point where you recognize these numbers, where you can see them and say, oh, hey, I know that number is a perfect square, like right off the top of your head. Now, 12 is not on that list. But what could I break 12 down into? If I want to break it into something times something, where one of the numbers is one of these perfect squares. Say it again. Whoever said it. 3 times 4, right? I could say that the square root of negative 12 is really equal to the square root of negative 4 times the square root of 3. Okay? Does that make sense? I could break 12 down into 4 and 3. Now, what's the square root of negative 4? 2i. And then square root of 3, I'm just going to leave as square root of 3. Okay, so if it says simplify and it's not a perfect square, what you have to do is think about what perfect square number goes into that, separate it, and then take a square root of the number that you can take a square root of. Okay, we'll practice more with that on the homework. What would you do with B? Solve for B. What would you do there? Yep, let's add 5. Plus 5 plus 5. That gives me 2b squared equals negative 50. Okay, what would I do from here? Yep, got to divide by 2 next. So I get b squared equals negative 25. And now, square root it. So what's the square root of negative 25? 5i. And then because I'm solving, I'm going to remember to put plus or minus in front of it. Okay, remember the plus or minus comes in anytime you see the word solve. How you feeling about my friend I? Yeah. This really falls under the category of math that just helps other math be easier. Like it helps you with, like as you get into Algebra 2, imaginary numbers are going to pop back up every now and again. You're going to start talking about imaginary roots and things like that. But like I said, practically this by itself, not super practical. Not difficult, but not super practical. Okay? Okay, I do have to go grab your homework off the printer real quick. Like I said, I was not prepared,